Hey folks, welcome back. My name is Doug, and in the last video in this series, I talked about how your code running in Cloud Functions behaves within a single server instance and among multiple instances. In particular, one important thing to know is that each server instance runs only a single function, and it repeats in response to incoming events. So, what does that mean for your function code, practically speaking? Well, a simple mistake could cause your function to run out of memory and crash unexpectedly. So, what do you need to do to prevent this? Well, there's two things that could cause problems for you, and those are global variables and temporary disk space. Both useful, but both dangerous if misused. First, global variables. The thing that may not be obvious is that all the variables you declare at the global scope retain their values between each function invocation on a particular server instance. When I say global scope, I mean everything declared at the top level in every JavaScript module that's loaded by your function. So, in this JavaScript function here, the Firebase SDKs are both held globally, as well as a reference to the Firestore SDK. Inside the function, the request and response objects, as well as user agent, are not. Unlike locally scoped variables that you declare inside a function, globals never go out of scope or get cleaned up, not even after your function code finishes. The objects will still be there during the next function invocation on that instance for as long as that instance is alive. Second, temporary disk space. In the Cloud Functions runtime, there's only one directory that's writable by your code, and that's temp. In JavaScript, you typically refer to it using the OS module using its tempter method for portability, because that location of temporary storage may be different than when running your code in the local emulator than when running in Cloud Functions. What you need to know is that temp is actually a memory-based file system. That means every file you write there actually consumes memory just like any other JavaScript object. It doesn't actually get persisted on a real disk somewhere. And, like global variables, it doesn't get cleaned up automatically when your function finishes. Now maybe you can see where I'm going with this. We have the possibility of both global variables and temp files holding onto memory after your function finishes. If these resources aren't properly managed by your code, you run the risk of exhausting memory in the server instance after your function executes repeatedly. And when your function runs out of memory, it'll crash, and you'll lose all your work for that invocation. At least Cloud Functions will deallocate the server instance when your function crashes, so that it won't continue to crash like that due to lack of memory. So what could we do to defend against this? Well, the obvious thing is to avoid globals and temp space altogether, if at all possible. Instead, prefer to store data in locally scoped variables so they get automatically cleaned up when the function finishes. Node has a buffer object that you can use to store chunks of binary data to use later, which you could use to avoid temp file storage. But sometimes it's valuable to store objects in global variables, especially if they're going to get reused for every invocation. For example, you probably don't want to pay the cost to initialize the Firebase admin SDK with every function invocation. It's good to initialize that just once and keep it around for later. That's an important optimization. Just don't let objects accumulate in global variables without strict limits. I will say that it's sometimes handy to store files in temp space, especially if you're working with other tools that need to read and write those files. For example, there's a command line tool called ImageMagick that's pre-installed on Cloud Functions instances that can read and modify images that you stored in temp, and it will also write out files to temp as well. But you should be very careful to remove those files before the function completes, because if you don't, they'll just accumulate over time, use up memory, and again, crash your function. Think carefully if you really need to use temp space. For example, instead of using ImageMagick for image manipulation, consider using a library like Sharp, since it can work with streams of image data in memory using locally scoped streams of data, rather than with files you have to manually clean up. So, use your best judgment when dealing with globals and temp disk space. They can save you time and effort if used correctly, or backfire and leak memory if used poorly. Your function code should be ready to execute repeatedly on a single instance, but it should also be ready to execute in parallel when scaled up on multiple instances. In the next video, I'll share some tips to make sure your functions do the right thing in the face of concurrent execution. So, be sure to subscribe here to the Firebase channel on YouTube to get that when it's ready, and I'll see you then.